Welcome to our today's lesson. I'm your facilitator, John Gikonya. So we shall be looking at quality control and acceptance sampling. So today, our main objectives will be the following. We shall look at or try to understand what are control charts and what they are used for, their advantages and purposes, and then define several terms. Among them include defect and defective. Then we look at types of control charts and understand what is variable control charts. And under variable control charts, we shall look at the different types of control charts that we shall use, and also discuss how we can plot a certain kind of control chart. So like any other form of chart, so when we talk of control chart, so this is a graphical representation of the collected information. And the information that we are referring to in this case is the information pertaining quality standards. We know that in the world today, standard is paramount, and we can easily quantify some attributes. We can easily quantify some variables and also describe some attributes pertaining a certain product when we are analyzing the quality of a product. So it pertains to the measured or otherwise judged quality. And when we talk of measured, what we can measure is the variables. And attributes are what we can judge. So we can say that a certain product is good or bad, is effective or defective, whereas we can have some measurable variables such as the weight, the length, and so on. So in statistics, quality control can be implemented through control charts that are used to monitor output of a process and indicate the presence of problems that may require some correction, or it can be used to monitor processes where output is measured as either variables or attributes. So what do these charts do? So when we talk of charts pertaining a certain variable to a product, or charts pertaining to certain attributes to a given product, as we'll be able to say, like the pie charts and the bar charts and many other form of charts that we have, control charts detects variation in the processing and warns if there is any departure from the specified tolerance limit. So if we have an outlier, so we have a range of acceptable values that any given attribute or any given variable should not go beyond. So we can simply say that control charts are used primarily as a diagnostic technique. It depicts whether there is any change on the characteristic of the item since the start of the production line. So some of the advantages of control charts, we have quite a number. However, these are some of them. So control charts indicate whether a process is in control or out of control. So the two terms, in control and out of control, we shall be able to define them and see what we mean by them. It also determines processes variability and detects unusual variation taking place in the process. For example, if we are dealing with a production process, if there is a variation in the production process, we can be able to detect using control charts. It also ensures we have standardized quality levels, and it warns in time if the process is rectified, in time scrap, or can be reduced. So other advantages or purpose of control charts include it provides information about the selection of the process and setting of the tolerance limit. As we said, that they can act as quality control technique. So there are some terms that we shall define before we can look at the various control charts. When we talk of a variable, so variables are simply those measurable characteristics. For example, for any given product, especially physical products, we can measure the diameter, especially for cylindrical items. We can measure the length, and we can tell from the measurements, if we are doing quality control, that the measurement is within the acceptable range or is out of control. Then we have the attributes. So attributes are characteristics that cannot be measured, and we can only describe them. And remember, when we say that something is bad, or is good, or is defective, or is effective, sometimes may be relative depending on the quality levels that you impose. So the term attributes refers to those quality characteristics that conform to specifications or do not conform to specifications. So we can have good attributes or bad attributes, and we use them when the measurements are not possible, or where measurements can be made but are not made because of time, cost, or need. So some other terms that we shall come across in the course of our learning will be chance of variation. And when we talk of chance of variation, these are simply reasons for minor variations in the quality characteristic that are inspected. These causes do not cause the item to be rejected, as the variation are within the limits. For example, the tolerance level. Then we have assignable cause of variation. These are causes that are external to the processes and cause large variation in quality characteristic, making the item liable to be rejected. Then we shall also come across the terms type 1 error and type 2 error. And this is done, or this will come across when we shall be doing hypothesis testing, to test the hypothesis whether the level of qualities, the level of quality is within the acceptable limit or is out of control. And when we talk of type 1 error, this is an error in sampling inspection that may lead to the conclusion that the process is out of control, whereas the fact is that the process is operating as intended. Then we have type 2 error. This error occurs when the process is not working as intended, but sampling error cause one to infer that the process is satisfactory. Then we have some other terms that we shall come across in our learning, and this is what we refer to as the acceptable quality level, and this is the maximum percentage or fraction defective that is considered as the overall process. Then we have rot tolerance percentage defective, and this is the upper limit of the percentage of defective products in an individual rot that the consumer is willing to tolerate, or even if the process average is acceptable. This is also known as average, or so this is also known as the limiting quality level, or LQL. And we have two more terms that we will, 2 or 3 terms that we shall come across, and this is producer risk, and we denote that with alpha, and the consumer's risk we denote with beta. And the consumer risk is the risk of getting sample which has higher proportion of defective than the rot, thereby rejecting a good rot based on sample evidence. Then we have the consumer risk. So this is the risk of getting a sample which has a lower proportion of defectives than the rot as a whole, and thereby accepting a bad rot as a good lot. Then we have the last term that we shall come across, and this is average outgoing quality. And you see that in a production process, if lots that are produced have an average fraction defective, and if some of the lots which are rejected based on sample evidence are inspected 100%, and the evidence units are either simply removed or replaced with non-defective ones, the average quality of the output lot after inspecting improves. So some of these terms, we shall come across them in the process of our, in the course of our learning. But before we can go into detail on all of them, so maybe we need to understand what is this control chart. And a control chart is one that will involve, or that will have 3 things. So there is what we refer to as the central line, this one, CL, which is given by the average of the mean characteristic, or the mean of sample means. Then we have the upper contour limit here that is given by x bar, which is the sample mean plus 3 sigma. In this case, sigma is the standard deviation, and then we have the lower contour limit, which is given by x bar minus 3 sigma squared. So in the process, we've said that 2 things are important when it comes to quality control. So we have those that can be measured, which we refer to as the variables, and we have those that cannot be measured, which we've said are the attributes. And attributes, we shall need to differentiate 2 things: defects and defectives. So a defect is any item or service that exhibits a departure from specifications. So if you say that a given product should have the following specification, for example, other than those uncountable attributes, the length should be so and so, the height and so on. So if the item has characteristics or exhibit features or specifications that depart from those specified, then we say that that is a defect. Note that a defect does not necessarily mean that the product or service cannot be used. A defect indicates only that the product result is not entirely as intended. For example, we may have a crack on a glass, especially in the beverages, a crack on the bottle. If we are talking of the car shaft, we can have a bend. If you have a bend on the shaft, then we can say that there is a defect, but it does not necessarily mean that we cannot entirely use the product. So these are things that can easily be rectified. Then we have a defective. A defective is an item or a service that is considered completely unacceptable. So each item or service experience is either considered defective or not. There are only two choices. So we can either have a defective or not a defect. So from the sample of all the products that have been produced, so if this is the total value, these are the total products obtained, which give us the total set of all the products that have been obtained. So we can have a subset of either defects or defective products. So there are some given characteristics that are unique to a control chart, and as we've seen from the diagram, so we've seen that the control chart will have three things. We have the upper control limit and the lower control limit, and we had how we can, and there was how we can easily compute or plot the chart, but we'll be able to discuss that into detail. But we have a nominal value, and this is the same as the center line, which is given by the average of the mean or the sample mean. So we shall categorize or classify control charts into 5 different types, but that depends on the quality that we are dealing with. So under control chart, we shall do variable control, and we said that variables are those measurable characteristics, and then we shall have attribute control, and these are those that cannot be measured, so you can only describe them using words like bad, good, defect or defective, defective or non-defective. So under variable control, so these are the type of charts that we have. So we have an X-bar chart or the R chart. And then we can have a combination of X-bar chart and the S chart. So the three charts that are key here, which we shall look at, are the X-bar chart, R-bar chart, S charts. And under attribute control charts, we have 4. So we have P chart, NP chart, and then we have a C chart and a U chart. So comparison of variable and attribute chart, how do they compare? So variable charts involve the measurement of the job dimensions, whereas an attribute chart only differentiate between defective item and non-defective item. Simply mean that a variable chart will involve those measurable characteristics, whereas an attribute chart will involve non-countable, or those that cannot be measured due to some other factors. So a recap of what we had. So control charts, we saw that a control chart will involve the Cartesian plane. Here we have the y-axis and the x-axis. But then here we have the center line, which we called the mean of sample means, or simply the average. The mean of this statistics under consideration will be the mean of all the samples used, so that we plot the center line, or the control line. Then we have these two that gives us the upper and the lower limit. So how do we come up with them? So we first of all find the standard deviation, and the standard deviation is simply the deviation from the root of the square deviations from the mean, because we know that the deviation from the mean will sum to 0, so it is the root of the square deviations from the mean. So the upper, this one, the upper control limit, and the lower control limit indicate the threshold at which the process output is considered and desired. So if the attribute or the characteristic goes above or below the thresholds lines, then we say that it is undesired. At the end, we should plot the attributes of the individual samples depending on what we were investigating. And what we end up with is this. So we have the center line, then we have, which gives the average of the mean of the samples, and then we have the upper threshold and the lower line that gives us the threshold, beyond which then we can say that it is undesired. So if any one of these points go above these two lines, then the process is said to be out of control. So those that falls between here, then you can say that it is in control. So there are two basic principles that we apply when coming up with control charts. So we have one, a process that is operating with only chance costs of variation present is said to be in statistical control. So I want you to note this, chance cost of variation. Then we have a process that is operating in the presence of assignable causes. So we'll be able to see what are assignable causes. Chance of variation is said to be out of control. Then last we have the eventual goal. the evaluation goal of these charts is to eliminate variation in the process. So we have described some, I think 7 or so types of charts depending on the quality control that we are undertaking. And I want to give you an overview of what we mean by those different charts. So we have an X-bar chart. So it shows the changes in process and is affected by changes in process variability. 2, it is a chart to measure the central tendency. It shows erratic cycle shifts in the process and also detect steady progress changes like wear in tools, changes in length for different products, and so on. Then we have a combination, as we'll be able to say, whereby we can have an X-bar chart and an R-bar chart. And when we combine them, it tells you when to leave the process. It secures information in establishing or modifying process, inspection procedures, and also controls the quality of incoming materials. So when the two are used, X-bar chart and R-bar chart, so they can form a powerful instrument for diagnostic quality, for diagnosing quality control. Then we have now the R-bar charts. What are they used for? So R-bar charts are used to control general variability of the process and is affected by changes in process variability. So it is close to X-bar chart, and it is a chart to measure the spread. And normally we use R-bar charts together with X-bar charts. And as we'll be able to say, X-bar charts and R-bar charts, we shall plot them under variability control, because this will involve those measurable characteristics pertaining to a given product. So the approach in which we use to plot them, and not only those charts that pertains variable control, but also those that pertains attribute control. The first step is to determine what type of data you are working with. So are you working with the average? Whatever type of data that you are working with. Then the second step is to determine what type of control chart to use. And as we have classified them, so those measurable attributes will fall under variable control charts, that is X-bar, X charts, R-bar charts, and so on. Then the third step is to calculate the averages and the control limits. And we said that the averages, we have the center line, which is simply the average or the mean of the average or the mean of the sample characteristic or sample statistic that you work with. And then we have the upper and the lower limit, and we'll be able to see how we can easily find them. So we can start with control charts for variables. And we said that a variable is that characteristic that can be measured. For example, the weight of a product, the volume, or the given dimensions. So the objective for this selection are to learn how to use control charts to monitor continuous data. So we want to learn the assumption behind the chart, the applications, that is the X-bar charts, the R-bar charts, and also how to interpret whatever we end up with. So since statistical control for continuous data depend on both the mean and the variability, so variable control charts are constructed to monitor each. So here we shall use X bar chart, which is the most commonly used. But we have other such as L bar charts, X bar charts, and S charts. So we have three categories of variation, and there is one we refer to as within piece variation, where one portion of surface is rough than another portion. So this pertains to a product, and whereby you can talk of it is one of the surface is not as required, varies from the other, which is smooth. Then we have a piece-to-piece variation. So this variation among pieces produced at the same time. So when we have an automated production process, and then some pieces are produced, and there is a difference between them, then we have a piece-to-piece variation. Then we have time-to-time variation. So service given early would be different from that given later. So this varies between time and time, and this can be as a result of the technological changes that have been made on the production process. So we have some causes to this variation, and we can categorize them as to either chance causes or assignable causes. So chance causes are those that inherent in the manufacturing process, so by virtue of operational and constructional features of the equipment involved. And they may result from, for example, in the production processes, either there was a vibration in the machines involved, then the voltage variation resulted to some defaults, and then we can have the materials used had a different composition. So chance variation are difficult to trace and difficult to control under best condition of production. Even though it is possible to trace out, it is not economical to eliminate. So when we are doing quality control in such case, then those variations may not be viable at the end. Then we have assignable causes, and these are the causes which create ordinary variation in the production quality. And assignable causes may result from either lack of skill in operation, long maintenance practice on the equipment involved in the production. When we have a new vendor to supply either the raw materials or to do a certain intermediate production process. And when we have errors in setting the jigs, this is with regard to mechanical production and fixtures, and when the materials supplied are defective. So we can visualize the production, the quality control as shown here. So we have the input, then we look at what causes the variability, and that is the main process involved, and we have the output at the end. So we've said that under variable control, we shall have a number of charts involved, or a number of variable control charts, and we had three of them, and one of them is the X bar. So this is called the X bar because the statistic being plotted is the sample mean. So we have various samples obtained from the production process, and then we have the means of those statistics obtained. So the reason for taking a sample is because we are not always sure of the distribution process. And at times, it can be time-consuming to come up with or to correct all the data involved in the production process. So by using the sample mean, so we will apply some central limit theorem so that we can assume the normality. Maybe to give you a picture of what we intend to have, so it's something like, so we have the center line here. So this is our chart, our x bar. No, this is our x-axis, and this is our y-axis. Then we have the actual process mean, this one, which is the center line. And then we have the upper contour limit and the lower contour limit. Then these are the individual means from the given samples. So those samples whose means go beyond this threshold, then they are considered undesirable. Then we have the R charts. The R chart is used to monitor process variability when the sample size is small. And in this case, we refer to as small when n is less than 10. So in some cases, especially in statistics, when n is less than, that is also considered. So this chart is called R chart because the statistic being plotted is the sample range. Range is the difference between the highest and the lowest, or the difference between a variable and the other. So here we have a sample R chart, and as expected, we have the center line here, so which is the average of the range. And then we have the lower contour limit, and then we have the upper contour limit. We said that to obtain the two, you need to compute the standard deviation of the statistic in consideration. Then last we have the S chart, and the S chart is used to monitor process variability when the sample size are large. In this case, more than 100 or more than, and the chart is called S chart because the sample plotted, or what we deal with here, is the sample standard deviation. So using the S chart, the estimate of the process standard deviation sigma is obtained, which will help us to get the upper and the lower control limit. Note that this one gives us the average of these individual points obtained from the samples, and the dot shows the standard deviation of the, or standard deviation from each of the samples used. So when we use R chart and X bar chart, they can be used to detect changes in the mean between groups. We've said that the R chart plots the range or the difference. So if you are dealing with sample means when we are investigating our data, so the X bar chart will plot the average of the sample mean, and the R chart will plot the deviations or the range between the individual means. So the R chart is developed from the range of each subgroup, as we had discussed, and the X-bar chart is so we plot the averages of the mean. Then we can also have a combination of X-bar and S-chart. So here we are dealing with the mean and S-chart, the standard deviation. So we use them to detect changes in the mean between subgroup. So the S-chart is developed from the standard deviation, as you've seen, and whereas the X-bar chart is obtained from the sample mean. So the procedure in which we use to plot our data. So you've seen that we need three things, or two things. One, so depending on the statistic under consideration, so we will find the average of the sample statistic. Then, if we want to plot the X-bar chart, if we want to plot the R-bar chart, so we will need the range. You said that the range is the difference between the maximum and the minimum. And then we also need the standard deviation, which is given by the root of the unbiased estimate of the variance. So after correcting a sufficient number of the sample, and normally the acceptable values or the acceptable sample size is one that's above 20. But to get a good representation of the actual process or the whole population, then it is always good to work with as large sample as possible, depending on how much data you can correct. Then, after we have plot, if we have a plot of the X-bar or the Y, the X-bar chart or the R chart or the S chart, if any points fall outside of the control limits, then we can conclude that the process is out of control. So the upper and the lower limit that gives us the threshold out, from which then we can say that the process is out of control. So when the special cause of that outlier is identified, then we remove that point, and then we should repeat the process in step 4, and then reevaluate again. Maybe we can look at an example and see how we can come up with the given charts. So here I have an example. So a large hotel in a resort area has a housekeeping staff that cleans and prepares all the hotel's guest rooms daily. In an effort to improve service through reducing variation in the time required to clean and prepare the room, a series of measurements are taken. A series of measurements is taken of the times to service rooms in one section of the hotel, cleaning times for 5 rooms selected each day for 25 consecutive days is recorded as follows. So we have the first column where we have the days, and this one has been done for 25 days. So we have 1, 10, then we have the room, the time taken, then we have room 1, room 2, all the way to room 5. So the days are 25. So in this case, we will need to calculate the average. This is the mean. And then we also calculate the range and the standard deviation. And the formulas to use are as follows. So this is summation of x I all that over n. And from my workout, these are the values obtained. X bar 15.94, R bar 2.7, and S bar, or the average standard deviation, is 1.14. And I can show you how the given charts or the given tables have, or the working has been done. So the resulting constant for X bar and R charts and those of S charts can be given as follows. So the center line, which is the average of the sample statistic used, we have 15.94. The lower contour limit is given by, so this is the mean, and then the standard deviation, which we've obtained as here. This is so this should be the standard deviation of the standard deviation of the statistic used, which has so the upper contour limit in this case we have 17.49. The lower contour limit is 14.38, and for the given charts that we have obtained. So here we have X bar and R chart combined, and X bar and S chart combined. So we can plot them as follows. So this is a compute output. So here we have the upper contour limit and the lower contour limit, and these are the individual points for the averages of the time taken to clean each room. And then here we have the R chart for the range. So the upper contour limit as computed, the lower contour limit as computed, and the center line, or the average of the range. Then we can also have the output for both X bar and S chart. So this is the upper contour limit, the lower contour limit, and then the center line, the average of the sample statistic under use. And then we have the S chart for the individual standard deviation. And we can be able to replicate this type of information or this type of charts for any given measurable variable that can be obtained from the production process. So the other charts that we shall be able to investigate will be those that fall under attribute control charts, whereby we shall say we have a number of them. We have about 4, and we will be able to compare at the end and know under what circumstances do you end up with an X bar chart or an S chart or an R chart, all those charts that fall under attribute control charts. We said we have pay charts and pay charts and so on. So that will mark the end of our today's lesson, and I would like you to try and work with a different example and see what will be your output, as we will say in our next lesson how we can come up with attribute control charts. Thank you.
These televised lectures supplement our robust online learning going on our MKU online platform. You can view more on our televised lectures via our online platform. We are in a digital era, and Mount Kenya University knows this. The following are the steps to follow so as to complete your online application. Download the application form from the website www.mku.ac.ke. Attach copies of your academic certificates and ID. Pay the application fees via M-Pesa pay bill number 270988. Your ID is the account number. 2,000 shillings is the charge for a postgraduate. You can also deposit in the bank accounts provided on the website. Then email all the above to apply@mku.ac.ke.